Hello. Yeah, welcome to Midas. Myself Abhishek. Today I am giving you the presentation regarding the Midas Gen. So first of all, I just wanted to ask you whether can you hear me? Just type a message in a chat box so that I can understand that you just hear me. Can you hear me?
Yes.
Okay, so we started regarding the introduction about the Midas Gen. Okay, so Midas Gen is the one-step solution for the building and the general structure. If you have any doubt or any question, you just type in a chat box so that I can give you the reply. So thanks for coming and listening this introduction presentation regarding the Midas Gen. So Midas Gen is the one-step solution for the building and the general structure. Why we are saying this one-step solution for the building and the general structure, that I show you in the demonstration time. So it's a complete one package, so that you can whatever that concrete structure, steel structure, plant structure, any type of the structure you can model in this software and you can get the design also. That's why we are saying that it's a one-stop solution for the building and the general structure. So that content we are in the line is the modeling, the boundary condition, loading, analysis capabilities, post processing, and the design capability. So these are the contents I covered in this presentation. So this is the GUI of our Midas Gen. So you can see this is the various the GUI means it's a very user friendly and very dynamic view. So why I said this dynamic view, that I explain in the furthers. So these are the various useful function of the windows. So in the first is, this is the multiple viewpoints and the table. So you can see the various views and the tables and the one diagrams. This thing. The second view is for the transparency. Means you can see the transverse view, even you can see the frame view, hidden views, and even the inactive hidden view also. And at the time you can see the tables also. In the last view you can see the table view, even the walkthrough view also we have. And similarly some various type of the graphs, if you wanted to see the graph at the time, so 3-4 window you can see at the time. So that type of the window also, that facility we have. The most important is the data exchange. Data exchange means what? The most of the time what happens, you can exchange the data from the Revit, the Tekla structure, STAD, ETAB, this type of the structure, this type of the software if you are using. So you can directly import it from that file and you directly work on the Midas. So it's up to you. So if you have any files, if you are using the previous software, you can directly imported that file into this Midas Gen software. And even you can AutoCAD DXF file, that SAF file, this type of the file, that multi files, any type of the files you can just import it into this Midas Gen. So this is the data exchange. So that Revit, if you model in the Revit, you can import it into the Midas Gen. Again, you analyze and design. Again, you export it into the Revit structure. This is type of the import and export function we have. So it's very good interface with the Revit. So this is the another one model. So if you are using the STAD file, we have the command shell file, means that is the text editor file. If you are using the STAD, so you just edit your text editor file. Same, we have the one option, that is the MGT command shell, so that you can edit the text file. For the modeling merge function, if you are doing the 3 buildings at a time, that podium is connected to each other. So that time what you can do, you can your engineer, if 2-3 engineers working on a modeling, so you can give the one model to the one engineer, second model to the second, third model to the third person. So that three model you can merge in a one file. That is also that one function we have, the merge file. So at a time, various files you can import it in this similar Midas gens. So now the material data definition. So generally the most of the things what happen, that you have to just modify the material database according to the your use. But we have the database according to the code. So that is the British Standard Code, American Code, European Code, IS Code, Japanese Code, Korea, Chinese. These are the various types of the code we have. So according to the code, if you select the material grade, entire database is generated. Means that modulus of elasticity, what is the modulus of elasticity, concrete density, everything is comes according to the code. So no need to modify anything. You have to just select which type of the grade you want. Similarly, that we have the good option, that is the creep and shrinkage and the compressive strength. So this is the time dependent material. So that is the good feature in our software. Generally that Burj Khalifa building, that world tallest building, initially started designing in the ETAB, but afterward because of the axial shortening, so they are shifted to the Midas chain. So in the Midas chain, that creep and shrinkage and the compressive strength, that is the time dependent material facility we have. So you can see this is type of the one yield stresses. Generally that yield stress according to the thickness it varies. So our program is automatically take care of these things. So this is the render view of our various section. So you can see the line diagram also, and you can see the various render diagram also, and the section that I show in this diagram, that section which is according to the BAS, AISC, the various code we have. You can directly import that file. You can if you have any odd type of the function, that section, so that file you can import from the AutoCAD to directly into the your software. So it's not showing in the one line diagram, it's showing in the render view also. So you can feel whether the which type of the section is there. So this type of the option also we have. Even the tapered section type of the section also you can do in our software. So this is the wizard. So I just tell you about the things, and afterward I directly show you about the Midas gen. So I directly work on the Midas gen so that I can explain you about brief about how our software is working. So this is the wizard. Wizard means generally if you wanted to do something fast modeling work, so that type also option we have, that is the beam, column, arc shape. That is the arc shape. If you have the plan in arc shape or in the 3D in arc shape, that type of the structure also you can do. That frame truss, that truss, if you are using the industrial shade and these things, that truss making is taking the so much of timing. But in our software we have a one database. You have to just click that truss and which type of the panel, so it's automatically generate the truss, and you can place whichever point you want. Similarly, plate, shell generally that option we are using for the underwater tanks and this type of the tanks, odd shape of tank. You can see in this view that odd type of, this is the underground tank. So you can model it in our software within the 5-10 minutes. So this is the diaphragm. I directly go to our software so that it's easy for you to understand. So this is our software, and in our software we have the good option. Why I saying this dynamic and the very effective software that I explain you. See, this is the first that GUI of this our software. In this the top view, you can see that this is the various options. So first, generally if you are doing any designing, you have to first model your structure. Means what? You have to first define whether you have to modeling in the 2D plan or the 3D plan. That is, you have to define in the view option. Then second is the which type of the structure is there, whether it is the 2D structure or it's a 3D structure, and even the grid line and these things you can define in the structure. The next is what you are defining the node and elements. So first you have to define the nodes, and then from the node you can generate the column and these things. So this is the option we have. So means first is the first you select all the, once you draw the grid, now you go to the modeling style type. So in the modeling you have to use that node and element, and then in the property you define the property and then you assign the property. Means whatever the sections are there, according to that you define the properties. Then now the next is the boundary condition. Means boundary means you define the support condition. So then next, once the boundary is done, you're going for the load, and once the load everything is done, that analysis part, you analyze the your structure and then you check the results. Once you check the results, we go for the design. Okay, this is the type of our design process. Same process we follow in our GUI. Its entire things is set as per the practical view. Okay, so now I show you about the our sections and the render views. File, new projects. Yeah. Okay, so this is the view. I just generate some properties. I show you. In the property we have the material property. So I just click on the material property. I say add. In the add option, say the type of the design. We have the various type of the design. Steel, concrete, SRC. SRC means steel reinforced concrete structure, or user defined. User defined means you have to define manually. So generally we are using the concrete structure. So I will click on the concrete. So you can see that standard Eurocode. Once we selected the Eurocode RC, and from the database, the which type of the code means that grade you are using. If you click that C2025, so modulus of elasticity, Poisson ratio, thermal coefficient, entire the things are changed. Then you just click OK. Nothing. You have to only define the code and the database. And now if you already prepare some files, existing files, so if you wanted to import some data, you can directly import it. You just click on the import. So from the n number of files, n number of the data, you can import it. Generally in the most of the software you can import the one file at a time, but in our software we have that good option, so you can directly import it file from your previous file, n number of files, and the whatever the data you import that you want, only particular that data you can import it. So this is the good option for you. So and now I show you about the sections. So in the section, once I click add, see the database. In the database you have to just click the code, which type of the code you want. According to the code it show you the sections. Okay, and similarly in the edge section, see the various type of the sections are there. L angle, C channel, which type of the section. If I click edge section, according to the code it show me the database. If I click the any one file, the entire the things is automatically change. Okay, so it's automatically take as per the your convenience or as per the your code. Even you can select in the user. If you click on the user, you can manually add the data. We have that type of the options also. You can manually add the data and just click OK. Even in the value, you can import or you can manually import the data. SRC section, that is the steel reinforced concrete. So that concrete data you have to define the concrete data, and the steel data you can define. So we have that type of the option also, means that composite section also you can model in this software. And in the combine means if two type of the sections are there, so you can model it. You just select the property, that data one means which is the one property, and the second property it automatically club the composite as some one member it's considered. And the tapered section is the good option. Generally the more if you are the initial size is the different and the end size is different, so the tapered section is generated. So most of the software we are not modeling this type of the beam because of this option is not available, but in our software we have that option. I show you what is the use of this option. in the my next section. And that composite section also we have that if we are using the two type of the material. Now I just model the one structure. So for the modeling, I go into the node and element and I say create node. So I just generate the one node that is apply in the 0 0 coordinate. So you can see in this, I select this coordinate. In this we can see that node number. Here is the element number is there. Just now I create a one node, so it's coming the one node. I just wanted to copy the one this node at in the X direction. So I just select, and whatever command you want, you just right click on a screen. You can see the command. I just click the nodes. I said the translate because I wanted to copy. So it's a copy. I want the copy 4 meter and it's a 4. So I said apply. See, these are the in the vertical direction. It's some view type of the option. See, I said zoom fit. So you can see now. This is the 3D view, and the view option also here. You can see the view options. Similarly, again I select all these nodes and copy it into the Y direction. So I just copy. I said my distance is 0, 0, in the Y direction. Now I say it's a 4 and the X number is 4 times. I just copy. Now in the zoom field, now you can see this type of the things. Okay, if I click, this is the isometric view. This is the top view. I just click, this is, you can see now the top view. Even you can see the right view, right side view and the left side view. And is the isometric. You can see the any type of the views. Now I generate some database. In the property, I click the material property and I said add. Once I click add, that I generate the one concrete structure. So I click to the concrete, and similarly I click on the EN code and I say it's a 2025. And you can see that modulus of elasticity, Poisson ratio, everything is changed. I said apply. Once I click apply, the command is working, and you can see here that these things are here. Similarly, now I am doing the second property 25 30, or I said 30 37, and I said okay. So you can see here two properties are there. Now I go to the sections. I say add. In the add, now I click the solid rectangular. For the RC section, I am using the solid rectangular section, and I said name, it's a column, and I said user. I give the size name is 450 and 450 means 450 by 450 mm. You can see the dimension is in meter. That's why I'm saying it's a meter. I said apply, and now here I say it's a beam. H means is the depth 600, and it's a 300 means 600 by 300. I say apply. Even I generate one new column property. I said column 1, and that size is my 0.5, or maybe I said okay 0.6, sorry 0.3 by 0.6. One more property I generated so that you can see how we can assign those properties, and I said close. Now I just select the nodes. Here is the one option, select all. I click all the nodes. I say right click on the screen and I say element extrude. Okay, I just right click on the screen. I say element extrude. Once I click the extrude option, node to line element, there is the option is node to line element. So we have that three type of the option. Node to line element means what? Your node, it became the line. Similarly, line element to the planar means your line became a slab, you can automatically convert those element to the other factors. Similarly, the planar element also you can make into the solid structure. So now I just want to note to the line element. A material grade I selected 20 by 25 and I select the column. First I for the column, and in this distance I'm giving it's 3 meter, means it's going above. In the z direction I'm giving distance, x is 0, y is 0 and the z is 3, means I wanted a column in the z direction, and I say apply. See, now you can see entire column is generated. Okay, once this column is generated, I just show you in the 3D view. Here is the rotate dynamic option. You can see you can rotate your file in any direction. It's depending upon you in the which direction you wanted to rotate. It's we have the one good option. So in the option you can directly rotate the UR file. I just save this file in my desktop. And even though we have the good option, you do not save your file regularly. It's automatically save the file. Okay, so I just see this view. Now that good one more good function I just told you. I just click on the works, that this is the tree menu. This is the very good option. So I just click on this works menu. See here, whatever the in the black color, that property we are using, and whatever in the blue color, that property we are not using. So see here, I just generate some column. In the column I just use that C20 by 25 property, that for the material property, and for the column I am using this only one property. Now beam and the column one property I am not using. Okay, so now I generate the beams. Before generate the beam, I wanted to show you about this. If you wanted to change the internal column, so I just click on this select line element. I just select this 1 2 3 4 5 6 7 8 and the 9 column. Once I select this, for the assigning, I just click this column 1 and drag it to the screen. Okay, I just first select the column and then from tree menu I drag it to the screen. Once I drag it, you can see the column is changing, the size, everything is changed according to the, only you have to just drag and paste it into the screen. Now similarly, now I do going for the draw the beam. I just go to the node and element, just click the create a line element. So just create the line element. My element type is general beam and the tapered beam, that property. So I see initially I click the C20 by 25 and my beam, I click on this option. I just click first point and last point. Once I click first point and the last point, whatever the entire intersections are coming, it's automatically break the elements. Whichever the nodes are there, it's automatically break. See here again, I just click from one point to second point, it's automatically break the element. So no need to worry about this. You have to just click one point to next point, it's automatically break everywhere. So first I draw the horizontals and the vertical beams. Yeah, so this is the option we have. So once this model is generated, you can see in the 3D view. So this is the model. Now see, I just click on this option, that front view. Okay, so I just click that XY plan. Now you can see only that vertical plan is selected. So I just wanted to change the grade. Now I again click C30 to 37. Okay, I just click here and drag it to the this screen. So it's automatically change now. If I click C20 to 25, just double click on this, you can see only the vertical member is selected. If I click C30 by 37, only the horizontal beams is selected. So if I click column, only the column is selected. If I click beam, the beam is selected. If I click column 1, only the entire column is selected. So that is the use of this work tree. So it's very useful for you for doing the modeling things. It's fastest and the easiest way. So now next, see the most of the software, it's working in the Centerline program. So now you can see here everything, the beam and the column is set in the center. I wanted to flush this beam to this top point. So I just go to the structure and say structure type. In the structure type, my structure type is 3D, and I said convert selfers into the masses. So its option is used for the calculating of the earthquake things. And I said this align top of the beam sections and align top of the slab. If I model the slab, then it's fine. If you do not model the slab, then also it's fine. I just click on this option, and you can see. I just zoom it here. See, now entire the top point is flush. So if you want, you can do in this way also. Similarly, now I just wanted to copy this structure into the some floors. The before doing this, I am just showing about the load things. Okay, in the load, we have the various type of the option, that is the static load, dynamic load, settle temperature pre-stage, construction stage, load tables, moving load, heat of integration, various type of the option we have. Okay, so we can model or you can design your structure according to the your use. Okay, now I just again back to the my slideshow. So this is the my that automatic generation of the story and the flow diaphragm. So this is the use when the diaphragm means what? It's a transfer the your lateral load to the vertical elements. So it's automatically program calculate the your CG point. According to the CG points, it generate the diaphragm, and you can that from the according to the diaphragm, the your lateral load is applied and lateral load is transferred to the connecting points. So it's whatever the your lateral load is there, it's automatically transferred, and the diaphragm, that is the action, it's automatically generated by the program. So how it's generated, that I show you. So this is our one structure. I just generate the 1-3 models. I just select this structure and I go to the structure, control data, and I say building generation. In the building generation, the number of copy, I set 4 numbers. My distance is 3.1 meter, and I say add, and I said apply. Once I say apply, now in the 3D view, you can see the entire structure is generated. Within a few seconds, you can generate your structure. Okay, so now I go to the control, again go to the structure, control data, and I say story. Because of the lateral load, the program doesn't know the which floor you wanted to consider for the lateral loads, whether it is in the wind for the wind condition, whether it is in the earthquake condition. So I just say here auto generate story data. So whatever the story we generated, it's automatically considered, and I said close. Sorry. We have the good option, that is the display. Just go to that view and the display option. So in the display option, we have the good function. So I just click that boundary and I set story diaphragm and say okay. See, you can see this story, and we have the good option, that is also one in that all that inactive active identity. I just click on the story and I said if I wanted to see the second floor, so I said both means what? It's showing the above and the below points also. Now I want only the below points, so I say click OK. So it's only showing the that particular level and the bottom column. Similarly, I said above, so it's only showing about the column and the your floor. And if I say only the floor, it's showing me the floor. That type of the option also we have. If you have any question, you can directly just type in a chat box so that I can tell you about this if you have any doubt. So far, I can just explain you about these things. Now the next is that this is the for the diaphragm generation. Now I go to the next slide. Meshing. Generally auto mesh, this is the option we are using for the flat slab. If flat slab means this is the entire slab without beam inside of the, only the beam is in the periphery section. So if you are using the ETAB, SAB, so it's auto mesh option is there, so it automatically generate the option that slab meshing means the slab is designed by the finite element analysis. So in this our software that you can design the your beam, column, slab, raft, footing, entire thing you can model and design in our software. So we have that type of the capability also. And if the meshing is a very tedious job, so if you are doing the meshing, so that if one panel is 2 meter by 2 meter and another panel is in different size, the meshing is not matched, and because of that not matching with the meshing, some type of the error is coming, or maybe sometimes the load is not transfer. But in our software we have the good option, that is the auto meshing. In this auto meshing, whatever the internal nodes are there, that program automatically take care of these things. So I just show you in the my modeling things. I just open the new slide, a new view, again the new sun. Yeah, so I just opened my previous file so that it's easy for you to understand, and we are not going to give the more timing. Flat slab. So see, this is the one the building is generated. So if you wanted to make some meshing that slab, so don't make the slab first. You just go to this option, node and element, click the auto mesh. I say auto mesh. In the auto mesh, which type of the option we selected? We have the one nodes, so you can just select the nodes, and the next is the line element. So you have to just select the entire line. Next is the planar element. So now I select the nodes option. So external node I just selected. Include the inner, include the boundary condition, the length, that mesh size I consider the 1 meter, element type I consider the plate, and the material I consider C30, that is grade of concrete, and the thickness I consider 200. And now I just select these nodes: first, second, third, fourth, fifth, sixth, 7th, 8, 9, 10, the whatever the periphery point is there, I just click and I say apply. Once I say apply, now you can see the program is automatically consider this mesh. I just see, and I just close this node option. Yeah, so you can, I just directly it's automatically generate the mesh, and you can see here that this is the opening, that is the lift, it's automatically take care of these things also. So this is also that good option, you can use this option. So it's within some few seconds I generated this my element. Now if I wanted to mesh my wall, that shear wall, so I can mesh it. I just show you how to mesh this option. Okay, I select this wall and I said planar element. Now because it's a planar element, that is the element, so I just selected these two lines, and now I say it's a 0.5 meter. So previously it's 1 meter. Now what happened that I wanted to show you, I just click this element and I just change the thickness, it's 250. I say apply. Now you can see, yeah. See here, the initially my size is 0.5 by 0.5. Once it's go above, that size is increasing. Why it's increasing? Because whatever the nodes are there, according to that nodes, my program it's, see here, this is my slab points, these 2 points, because it's a 1 meter by 1 meter. So according to these points, it's automatically merged. So it's automatically generate that element. So no need to worry about these joints and these things. The program automatically itself consider these things. This is the hidden view. And if you wanted to see the everything, you just click on this option, hidden. This is the solid view. You can see any type of the view according to the UR use. So now this type of the section also you can done. Now the taper section. So this type of the section, initially it's a 1 meter by 1 meter and at the end it's 0.5 by 0.5. But if your structure is divided into the number of parts, see it's the number of parts I wanted to divide it. So you have to calculate the every each and length. So what is the this start end and end end, start point, end section, start section, end section, whatever the sections are there, you have to calculate it. Now I just show you in this. I just open the new project. So I just create some nodes. That material is okay. I just add some material, that is the concrete structure, and it's okay. And I select the any one property, and in the section add. Once I add, I just set the tapered. In the tapered, I select the solid rectangle. Initially my size is 1 meter by 1 meter, and after the at the end it's my 0.5 by 0.5. The rest of the things are same. I said okay. I have to give the name tapered, and I said okay. Once I click OK, now I generate the beam. I use the one grid line option, so it's easy for me to understand. So this is the 2D view, and I just generate the beam tapered section. This tapered from here to here, here to here, here to here, and here to here. So see, you can see this. I generated this type of the section, but my size is here different. Here it's automatic. It's a 1 meter by 1 meter. I just show you in the 3D view. Yeah. See, this is the 1 meter. This is the 0.5 by 0.5. It is the 1 meter by 1 meter, again 0.5. I want the initial, this size is 1 meter by 1 meter and the end is 0.5. So I just select this entire property and I say right click, go to the property, and I say tapered section group. And I give the name tap 1. I say add and the close. Now you can see that initially it's a 1 meter by 1 meter and at the end it's a 0.5 by 0.5. But now I want that top point to be the flush. So I again go to the property. I say section property. In the section property, I just click the tab option. I say modify. In the modify, you can see this option that change offset. Change offset means you can change this offset. In the offset, that center to center, I say I want the center top so that my top is flush. I select click OK, OK, and the close. Now you can see this is the straight line that initially is 1 meter by 1 meter and at the end it's 1 meter 0.5 by 0.5. So this type of the section also you can do in this software. So we have this type of the option. Now my next slide. So it's a prismatic section. Any type of the section you just import it from the DXF file, and whatever the stresses you want you can find out from our software. So now I go to the boundary condition. In the boundary condition, we have the various type of the conditions, support conditions, and you can go for the higher analysis also. So beam end release, whatever the, if you wanted to release some beam, so means if you do not want to transfer the moment to the second point, so in the second nodes or second element, that is also the good option we have. And the support, in the support we have the various support condition, the means fixed support, pin support, hinge support, none support, even that's point spring, general spring, surface spring, pile spring, elastic link, various type of the option we have. See, this is the one type of the shear wall at under the earth, under the ground. So if you, that pressure loads are coming into the shear wall, that type also the, we can define the supports. So that type also the option we have. And even the, for the pile, see, generally if you model the pile, because of the your lateral soil, the negative frictions is generated, that is also you can consider at the time of the modeling. This is also the good option we have. Generally this is using for the soil structure interaction things, means whatever, if your building is going underground, so that is that time what is the effect of soil on your structure, that is also you can study it. Then now next is the base isolation energy distribution system, means this is the generally used for the control the your vibration things. So so means the base isolation, this is the one the technique, so that you can reduce your vibration of the building. So you have to, one mechanism that you have to install into the your building at the base level. So at the time of the earthquake, your building is entire the footing and this thing is move and again come back. So that type of the mechanism and the things you have to model, and that type of the capability also we have. That we have that viscoelasticity damper, high histostatic system, lead rubber bearing isolator. These are the type of the base isolation that we have. In the loading, see the various type of the load option we have. So what is that? Self-weight, nodal load, and the various type of the loads options we have. The means self-weight, nodal load, prescribed displacement, element beam load, line beam load, floor load, pre-stress beam load, pre-tension load, tendon pre-stress, hydrostatic pressure, the various types of the load option we have. So whatever the load you wanted to apply, you can apply. Now I go to the next option. So floor load, pressure load, and the hydrostatic pressure load. See, means the, what is the difference between these three things? So in the floor loads, means generally if load is one way or the two-way distribution, so you can apply this type of the loading also. If you want to do the pressure load, means it's a finite element analysis options, means you have to break the element and you directly apply the load, and according to the FEM analysis, it transfer the load from the one point to the next point. So that is also the good option we have. And the last option is hydrostatic pressure load, means if you model the one dam or maybe if any retaining wall, so whatever the triangular type of the loading is there, so you can apply this type of the loading also. So now the static wind and the seismic load. Now I just show you in this into the my modeling, so it's easy for you to understand the which type of the, how the loading and these things are considered in this our software. I just opened my previous file and I said it's untitled. Okay, this is the one file that I generated previous. Okay, so I just, in the load you can generate the static load cases, and these are the various options we have. Means we have to first define the cases. I said dead. In the dead type, the various type of the options are there. You have to just select. I said dead load, so add. So you can see that this option is generated. I said live, so live load option also we have, live load, add. Similarly that wind load, earthquake, these are the various type of the options we have. You have to just add these load cases. Once you add these load cases, I just show you in this live modeling. Wind X, I say wind load on a structure, add. Similarly wind Y, add. I said AQX, earthquake X, earthquake, add. Similarly earthquake Y, add. And I say even, I say close. And if you wanted to add one that superimpose dead load, means it's other than the dead load, means in the dead load we consider the self weight. The program is automatically consider your self weight. No need to calculate the self weight. Program automatically calculate the everything. So I just close these things. I say in the self weight, I say dead load and I say -1, means if you have to give the gravity load, means in the -1 direction, so that program automatically calculate the self weight. No need to, you have to calculate and manually input. It's program is automatically calculate the things. I just click on this option and I generate, I said the bottom point. I just click this bottom point. I say right click, boundaries and the support. I just click on this option. I say D all R all, means now I want to fix my base portion, so that my column is now fixed at the base. Okay, now I click the entire beams and I apply the loading. I say element load SIDL and I apply, it's a -10 kilonewton meter. Say apply. Now you can see the entire these things is generated. Whatever that we define, you can see here the entire things is generated. Okay, and now I apply the floor loads. I just go to this load, initial force. I just click here, assign floor load and define floor load. If you are going for the one-way, two-way direction, you have to define these things. If you are going for the plate load, so you can model the your slab and you can directly apply the pressure load. So now I just click on this, define a floor load type. I say it's a typical load for the dead. Now I consider my slab weight, it's 100 mm thickness, that is the 2.5 kilonewton per meter square. SIDL, that is the floor finish, I consider it's a 1, and my live load I consider it's a -2. Whatever the value you are giving, you have to just define it's a minus value, so that it's going in the downstream, means gravity direction. I just click, see the type, dead is -2.5, SIDL is -1, live is -2, and I say add and the close. Now you can see the here. Now I again go to this assign and now I say assign floor load. Before going to the assign floor load, you have to define the on which floor you are doing. So I want in this level, that bottom at this level. Now I go to this option, active by identifying, that I previously told you. The story, I select the second floor and I say below, active and close. Now you can see this. I just click here, assign. In this assign floor load, I set typical distribution. In which direction the distribution you want, the one way, two way, or which. I said it's a two way and everything is 0. Here I want to copy this floor load in the Z direction. So in this Z direction I said 4 times at the rate 3.1 meter. Sorry, it's a hatch is coming at the rate. At the rate means what? The 4 means it's a number of the copy and 3.1 is the distance. Though I want the 3.1 means 4 number copy at the distance of 3.1 meter. Now I just click here, first point, second point, third point, fourth, fifth. It's automatically generated. Now you can see, I just click here and I say display. So you can see that the loading and these things are there. I just zoom it so that it's easy for you to understand. Yeah, see here, it's a 2 kilonewton, 2, and why the triangular loading is coming, because my panel is square. That's why this type of the loading is there. If my panel is the length and this rectangular, so in the shorter direction it's considered the triangular loading, and in the longer direction it's considered the trapezoidal loading. Now if I say active all, in the entire area you can see the floor load is generated. I say here on display. Now everything is gone. Now the next is the wind load. In the wind load, just click here. I say add. Once you click the add option, Windex, wind load case, you just click the wind load case. Now I say Eurocode 2005. According to this, the terrain category, enter the things you have to define. I set my velocity, the friction coefficient CFR. If you wanted to add, you can add the values, and the wind code I said it's a 30. That enter the things are direct X direction, C direction, enter the things I kept it the same. Whatever the height and this thing is automatically calculated by the program, and whatever the data you wanted to modify, you can modify. Now for the X direction I say 1, and for the Y direction I say 0, and I set wind load profile. Once I click in the wind load profile, you can see this type the profile is generated. Even I click the storage shear, this is the storage shear. Even in this option you can see wind force, what are the wind forces are there, storage forces, and this is the storage shear, means what is at the base, how much the shear is generated due to this loading. And if you click on the make wind load calculation sheet, you just click on this option. Once you click, you can get this type of the Excel, that WordPad file. In this WordPad file, enter the formula, which type of the formula is using, and according to the formula what is the values are coming, everything is mentioned here. So it's easy for you, according to the code, what are the values are coming according to the VR code, or which formula that software is using, entire the things are written here. So I think so it's easy to understand you, so which formula and the which things are using in our software. I just close this, and I say close, and I say apply. Similarly for the wind Y, rest of the things are same. I just say 0, and in the Y direction it's 1. Now again in the wind load profile, now you can see in the Y the values are coming, in the X enter the things is 0. Same thing you can see the make wind load calculation 6, enter the things are there. I just say okay. Okay, so you can see here this is the X direction. If I click here and I say display, it's in the Y direction. If you click on this option and say display, these values that in the green color, you can see these values in the green color. I say just see these values in the X direction, and if you click in the Y direction, you can see here I just click this right view. See in the right view you can see this here. So these are the value you can see in the display also. Now the next is the earthquake cases. I just click on the seismic load profile, add earthquake, Eurocode 8. Eurocode 8 option is there.
Eh. Eh. Tajua nashaenda kurekebisha. James. Wa fundi bomba. Anani? Sasa cha kufanya tunamsubia kwanza Andrew angalie.
Amna, kuna kazi nyumbani hapa.
Hello, can you hear me?
Yeah.
Yeah, okay.
Now I can hear.
Okay, up to what you are here, can you tell me? So last which slide you
Yeah.
saw?
No, actually from 6 o'clock actually.
Okay, I just show you. Yeah, up to this
From I think it was from loading.
from the loading.
Yes.
Okay, so I just explain you about this. So loading, you can add the loading depending upon the you have to just add the loading. So we have the good type of the option. So one way loading, two-way loading, pressure load. So this type of the option we have. The one way loading, you have to just define the loading and you can directly apply. No
Yeah.
need to model the slab because so it's automatically take care by the program. And if you model the slab, it means then also it's fine. You can directly apply the pressure loads. So this is the way. These are the two options we have. So if you model the slab, then also the program calculate the self-head. If you do not model, you have to give the definition, means in that area that much the self-head is coming. So it automatically take care by the program.
Right.
Okay, and generally which type of the structure you are doing, means that RCC structure or the steel structure,
What?
means
Sorry?
which type of the building you are design, means the reinforce
I think like for example here, like the same like what you show us here.
okay, okay, means RCC structure, that reinforced concrete structure you are using.
Yes.
Okay, so you can
Using the
model,
USM
yeah.
Euroco.
Yeah, yeah. So you can model it here, and if you are using the steel structure also, then also we have the good option that optimal design. So if you are giving the higher size of the section, the program give you the lower size also. So if you are using the lower size, then you can achieve the economic things. So we have that type of the option also.
All right.
Okay, and at the
So please, could you arrange?
sorry, I can hear you.
Okay. Could you arrange for another small session for this
Okay, so
course because you actually
okay, so up to which part you wanted to see?
because my network was stuck in somewhere every time.
Okay.
If
Uh,
we can, I can
uh,
connect it through.
Net. Can I send you the video files? This whatever I did
No, it's
today.
not easy. But
Yes.
we can use Team Viewer. Can you use Team Viewer so that we can model one file and then go?
Okay. So you wanted to do with the team viewer.
Yes, because you and me, and then you can show me here, you have to go here, you have to go there. Can we do that tomorrow? Maybe tomorrow.
Tomorrow. Okay. So I just do one thing. So I just send you the one link. So whatever I did, means whatever I show you, whatever the presentation I give you, that video I send you.
Yeah.
Okay. And
Yes. Yeah.
according to that, you just mail to the Saurabh so that
Yeah.
we arrange one another schedule for you. Is it fine?
Yes, it's fine. So yeah, it's fine. So could you send also for Tuesday session because Tuesday session I was not around.
Okay, 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 fine. We have the video, so we send it to you, and whatever we show,
Okay.
we that link we share with you.
All right. Thank you very much.
Yeah, thank you very
But
much.
also,
Yeah.
I was requesting something on Design Plus because the file I have here, the software I have in the Design Plus cannot give me exactly
Yeah, we have the
the
design
same.
plus option also. So I think we are in the maybe the May 11th we are coming in your country. So it's a good
Yes.
to means interact with you. So I request you to just attend our lecture so that it's easy for us.
Yeah. Do you think those 4 days would be enough for me to understand both?
Yeah, yeah, you can understand. It's not an hardcore because we give the on that training also how to use this software. And if you want to know about if you stuck anywhere, we give you the online session also. If we solve your problem, we have the good we
Yeah.
have a good technical team. You just mail whatever you want. We send it back to you within a 24 hours. So that is
All right.
also
So
the
could you come?
yeah, yeah, we are coming in your country.
Sorry.
We are coming in your country at
Yeah.
something 10 or 11th May, maybe on the second week of May.
Yes, I know that. So could you come with manuals, the hard copy?
Yeah, 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 hard copy also. We are giving the hard copy to you. So we are planning to give you the hard copy. So it's easy for you to understand the this Euro code and these things. So we are planning to give you.
Yes. Hard copies for both the software design plus GN and civil.
Yeah, yeah, for the civil also.
All right. All right. So anyway, so for that case, I don't have any option. So could you please send me this video and then I can try to work on it until Thursday. No, until next week. I can have something to ask you.
Yeah, surely, surely. In the next week, we are means arranging the one new session that is means for the how to modeling the RC building, how means the reinforced
Yes.
concrete building, how to model, how to get the design results, how to see the whatever the means commands are there. Everything we are showing in the next our training schedule. So try to attend that next schedule also. So it's maybe in the Tuesday or
Yes.
maybe in the Thursday. So according to that, we send the
Yeah.
link to you. You just try to attend this lecture. So it's easy for you to understand our software also, and it's to know about more detail about our software. Now I just show you about the introduction part. So exact thing I show you in the my next training schedule.
Okay.
Okay.
All right. Thank you very much. I
Yeah.
think we will meet on Tuesday.
Yeah. Surely. Surely.
All right.
Yeah. Thank you. Have a nice day, sir.